Arab Republic of Egypt. Ministry of Education. General Secondary Education Certificate Examination, 2011. Second stage, first session. Physics. Time, 3 hours. Question 1. 8. Mention one use for each of the following. Dewar flask. Model answer. Store liquid gases. Explanation. Dewar flask. It is a glass or metallic container, evacuated to prevent heat transfer. It is used to store liquid gases, since it is designed to prevent heat losses by conduction, convection, and radiation. It consists of a double-walled Pyrex container, with silver-plated walls, to minimize heat transfer by radiation. The spacing between the walls is evacuated, to prevent conduction and convection. Question 1. 8. Mention one application for each of the following. The electric motor. Model answer. Convert electric energy into mechanical energy. Explanation. The electric motor. The principle of operation of the electric motor, and that of the moving coil galvanometer are alike. The main difference is that the electric motor must rotate continuously in the same direction. The design of the electric motor necessitates that the two halves of the cylinder must interchange positions relative to the two brushes each half cycle. As a result, the electric current passing in the motor must reverse direction in the coil each half revolution. Question 1. 8. Mention one application for each of the following. The multiplier resistor in voltmeter. Model answer. Increase total resistance of the apparatus, so the voltmeter must draw a negligible current, so that it will not affect the voltage drop to be measured. Explanation. The voltmeter. It based on torque exerted on current-carrying coil placed in a magnetic field. It consists of galvanometer connected to large resistance in series. It connects to the electric circuit in parallel. It is used to measure the potential difference according to the relations. Question 1. B. Explain the scientific idea on which the function of the following is based. Laser. Model answer. Laser depends on driving the atoms or molecules of the active medium into a state of population inversion. Explanation. Stimulated emission. If a photon of energy E2 E1 falls on an excited atom at level E2 before the lifetime is over, this photon pushes the atom back to the ground state, and hence, the atom radiates the excitation energy in the form of a photon of the same frequency, phase, and direction of the falling photon. The stimulated emission is the dominant emission in lasers. Question 1. B. Explain the scientific idea on which the function of the following is based. Induction furnaces. Model answer. If the magnetic flux changes with time through a solid conductor, currents will be induced in closed paths in the conductor. These are called eddy current. These currents have a heat effect enough to melt metals. Explanation. Eddy currents. If the magnetic flux changes with time through a solid conductor, currents will be induced in closed paths in the conductor. Such currents are called eddy currents. The change in the intercepted magnetic flux is effected either by moving the solid in a suitable magnetic field, or by subjecting the metallic solid to an alternating magnetic field, for example field due to an AC current. The eddy currents are associated with heating effects. Thus, they are useful in melting metals in what is called the induction furnaces. Question 2. 8. What is meant by hologram? Model answer. An image with 3D details, as the reflected beam and the reference beam meet at the photographic plate, and interference takes place. After the photographic plate is developed, resulting interference fringes appear coated. Explanation. 3D image. It is characterized by intensity of light, amplitude, phase difference. 2D image. It is characterized by intensity of light only. Question 2. 8. What is meant by work function? Model answer. It is the minimum energy needed to free an electron from the surface. Explanation. Work function and critical frequency. The critical frequency and work function vary for different materials, and do not depend on the light intensity, the exposure time, or the voltage difference between the anode and the cathode. Question 2. B. Write down the equivalent unit of the following, and mention the physical quantities that are measured by each of them. Henry. Model answer. Equivalent unit. Volt second per Henry. Ohm second. Physical quantities. Coefficient of induction. Explanation. Mutual induction coefficient of induction. Factors affect mutual induction coefficient: the presence of an iron core inside the coil, the volume of the coil, and the number of its turns. The distance separating them. Question 2. B. Write down the equivalent unit of the following, and mention the physical quantities that are measured by each of them. Weber per square meter. Model answer. Equivalent unit. Tesla. Newton per ampere meter. Physical quantities. Magnetic flux density. Explanation. Stimulated emission. If a photon of energy E2 E1 falls on an excited atom at level E2 before the lifetime is over, this photon pushes the atom back. Question 2. A step-down transformer of 100% efficiency has 600 turns on its secondary coil, used to operate a device of power 48 watt and potential difference 24 volt, using an electric source of E.M.F 200 volt. Calculate number of turns in the primary coil, current intensity in the secondary coil, current intensity in the primary coil. Question 2. B. Write down. Question 2. A. What is meant by work function? Model answer. It is the minimum energy needed to free an electron from the surface. Question 2. A. What is meant by hologram? Model answer. An image with 3D details, as the reflected beam and the reference beam meet at the photographic plate, and interference takes. Explanation. Sensitivity of a galvanometer. The sensitivity of a galvanometer is defined as the scale deflection per unit current intensity flowing through its coil. Question 3. They write down the scientific concept for each of the following. The wavelength at maximum radiation intensity is inversely proportional to temperature. Model answer. Wien's law. Explanation. Wien's law. According to Wien's law, the starch which has blue color is higher in temperature than that of red color, where the blue has shorter wavelength than red, and wavelength is inversely proportional to temperature. Question 3. B. Mention the factors affecting the force acted on a straight wire carrying current in a normal magnetic field. Then, write the mathematical relation between the force and these factors. Deduce a definition for magnetic flux density. Question 3. Model answer. Factors affecting magnetic force, magnetic flux density, the length of a wire, the current intensity passing in a wire. The mathematical relation is F equals BIL. Magnetic flux density is the affected normal force acting on a wire of length 1 meter carrying current 1 ampere. Explanation. Force between two straight line wires carry current. Question 4. B. Mention the necessary condition for the occurrence of each of the following: vanishing of the electric resistance in some metals. Model answer. When these metals are at very low temperature near 0 Kelvin. Explanation. Wien's law. According to Wien's law, the starch which has blue color is higher in temperature than that of red color, where the blue has shorter wavelength than red, and wavelength is inversely proportional to temperature. Question 4. B. Mention the necessary condition for the occurrence of each of the following: the release of electron out of the metal surface when light falls on it. Model answer. When the frequency of the incident ray is equal or more than its critical value. Explanation. 3D image. It is characterized by intensity of light, amplitude, phase difference. Question 4. B. Mention the necessary condition for the occurrence of each of the following: vanishing of the induced current in a straight wire moving in a uniform magnetic field. Model answer, as the wire moves in a direction parallel to magnetic flux lines. Explanation. Force acting on a current-carrying wire. When the flux line is perpendicular to the wire, F equals BIL. When the flux line is inclined to the wire, F equals BIL sin theta. Question 4. Be compared between each of the following: Fleming's left-hand rule and Ampere's right-hand rule, with respect to application. Question 4. Model answer. Fleming's left-hand rule, used to determine the direction of the force, motion acting on a wire carrying current flowing perpendicularly to a magnetic field. Ampere's right-hand rule, used to determine the direction of the magnetic field resulting from an electric current in a wire. Explanation. Fleming's right-hand rule. It is used to determine the direction of the induced current in a straight wire intercepts flux line of magnetic field. Explanation. Force between two straight line wires carry current. Question 4. Model answer. Spontaneous emission occurs when the atom relaxes from an excited state to a lower state, emitting spontaneously the energy difference in the form of a photon without the effect of an external photon after the lifetime interval is over. Stimulated emissions occurs where an external photon stimulates excited atoms to emit the energy difference in the form of a photon before the lifetime interval is over. Explanation. Stimulated emissions. The emitted photons are monochromatic single wavelength. The emitted photons are coherent and propagate in one direction as a collimated parallel beam. The intensity remains constant over long distances contrary to the inverse square law. It has been possible to send a laser beam to the moon and receive it back, without much losses, despite the long distance involved. Spreading effect is null and limited scattering takes place. Question 5. A. Choose the correct answer from those between brackets. Monochromatic means that laser has one wavelength. A band of wavelengths doesn't obey inverse square law. Model answer. One wavelength. Explanation. Properties of a laser beam: monochromaticity, collimation, coherence, intensity. Question 5. A. Choose the correct answer from those between brackets. In the opposite figure, if the bar magnet is being moved towards the loop, the potential of point A should be greater than, less than, equal to the potential of point B. Model answer. Less than. Explanation. Lenz's rule. The induced current must be in a direction such as to oppose the change producing it. Question 5. A. Choose the correct answer from those between brackets. The ratio between the photon energy after collision to its energy before collision is greater than 1, equal 1, less than 1 in Compton effect. Model answer. Less than 1. Explanation. Compton effect. It was observed that when the photon X or rays collided with a free electron, the photon frequency decreased and changed its direction. Also, the electron velocity increased and it changed its direction. Explanation. Properties of a laser beam: monochromaticity, collimation, coherence, intensity. Question 5. A. Choose the correct answer from those between brackets. In the opposite figure, if the bar magnet is being moved towards the loop, the potential of point A should be greater than, less than, equal to the potential of point B. Model answer. Less than. Explanation. Redraw. Question 6. 8. What are the implications of each of the following? Passing of electric current in the same direction in two parallel wires. Model answer. Attraction force is generated between them. Explanation. Current carrying wires. If two parallel wires carry current in the same direction, the magnetic field between them will be in opposite direction, causing attraction force between the two wires. If the two parallel wires carry current in opposite direction, the magnetic field between them will be in the same direction, causing repulsion force between them. Question 6. 8. What are the implications of each of the following? The replacement of two metallic rings by a metallic cylinder split into two insulated halves in dynamo. Model answer. The alternating current converts into direct current. Explanation. Two metallic rings in the dynamo convert the alternated current into monodirection current. In the motor, reverse the direction of current each half cycle.